Hello everyone, Harry from GMAT Ninja here and welcome back to our GRE Quant video series. This episode's all about counting and sequences, which are two different topics, so we're going to split this video down the middle. I've got 9 questions for you today. The first 4 are going to be on counting, the next 5 are going to be on sequences. Now, to dig into more detail about what we'll cover, when we talk about counting, what we're talking about is summing large sequences of numbers. Think about what you might do if I wanted to add up all the multiples of 10 from 100 to 1,000, say something like that. I've got a large list of numbers, I want to add them all up and find the total. We're going to take a look at a couple of different ways the GRE might ask you questions about that. Then we're going to get into what happens when you've got a symmetrical or an evenly spaced set and how you can use that to make some of the questions look a bit more simple. Then when we get into the sequences bit, we're going to take a look at just how to interpret the sequences question. They can be asked in a variety of different ways and you need to know how to interpret them, and then how to understand notation. Some of the notation in the sequences question looks very intimidating. It's actually not that bad, but we'll get into the detail of what that means when we get there. So like I said, I've got 9 questions for you, 4 of them on counting, 5 of them on sequences. Now, if we talk a little bit about the difficulty level, I don't expect much of this video to be that tough. So if you're aiming for anything up to a 160, all you really need are the first 2 questions on the counting and probably the first 2 questions on the sequences. If you're aiming for something over a 160, stick around for the whole video. We're going to have some challenging ones later on. But if you're aiming for anything over a 165, I probably don't have a huge amount for you, except for maybe the last couple of questions on the video. So really, we're looking at the processes, we're looking at the techniques. And like I say, if you can deal with the first 2 questions for the counting and the first 2 questions for the sequences, you're probably going to be okay for anything up to about a 160. All right, so I will get the first question up on the screen for you now. Each time, I'll give you about 1:45 to take a look at it, about the time you would get to take a look at these questions on the GRE. Then I'll come back, take the question away, and we can have a look at them together. So, like I say, I'll get the first question up for you now. I'll give you the best part of a couple of minutes to take a look at it. Best of luck, and we'll see you back here soon. All right, as always in these videos, if you want a bit more time to take a look at this problem, now's your chance to pause the video, but I'll be taking this away so that we can take a closer look at this problem together. All right, so first question here, and you might have taken a look at this question and just gone, hang on, what does this have anything to do with summing up large lists of numbers? And that's a very fair question. What I'd say is that when we do get to summing up large systems of numbers, what we need to know is how many numbers are in our list. And that links almost perfectly onto what we're doing here. So I'm taking a bit of that summing process and just looking at it in isolation, and then we'll put it into the overall, into the whole when we get to the next problem. All right, so bear with me a second. This is going to be helpful. Now, in this question, I've got this scenario. I've got a city government installing speed bumps. I've got a road that's 330 meters long, and we're going to put a speed bump in every 16 meters. Now, this question is really, a lot of it's just about, be careful with your definitions and just don't get drawn into your initial assumption about the question. What I mean by that is, what most people will do when they come into this problem straight away is they'll say, well, I can put a speed bump in every 16 meters. So let's just use my 16 times table here. I could put a speed bump at 16 meters, and then the next one would go at 32, and the next one would go at 48, and so on and so on. And you could put one at 304 meters and one at 320. And what they do then is go, well, 320 meters, I'm going to put one in every 16 meters. That means I can get 20 speed bumps, and they'll just go, great, I'm done here. The answer is going to be C, and we're finished. Okay, what I'd say to that is, let's just pause for a second. First of all, you're totally right. 16 times table is valid here, but 0 is also in the 16 times table. Yeah, we've got 16 times 1, 16 times 2, 16 times 3. How about 16 times 0? Could I put a speed bump in at the 0 point? Now, in this real life scenario about the city government installing speed bumps, probably not. But I want you to remember this idea that 0 is also in the 16 times table. It's 16 times 0, yes, fair enough, but it is in the 16 times table because we're going to be using that later on. If I can put a speed bump at the 0 point, hey, I can add 1 onto my 20 list and the answer will be 21. Now, in this real life scenario, let's keep this 16 times 0 in mind, keep all of these in mind, and what happens if I shift everything down 1? So I can put a speed bump at 1 meter, and at 17 meters, and 33, and 49, 305, and 321. Well, now, still use that 16 meters, they're still 16 meters apart, but I found a way of getting that extra speed bump into there, which means that we're one more than that 20 that we thought initially. And so the answer to this question is going to be D, it's going to be 21. All right, so when we get into the summing questions, which I'll put up on the screen in just a second, I want you to bear this starting point in mind. In this real life scenario, we could have made the argument that 16 times 0 didn't count. I can't put a speed bump right at the start, but it is in the 16 times table. So when you go 32, well, divided by 16 gives me 20. That was probably one less than we needed because we could have fitted another one in right at the start. And we're going to see that idea pop up a lot in the next couple of questions. All right, so I'm going to get just a straight, let's sum a list of numbers questions up on the screen for you now. As always, just a little bit under 2 minutes, and I'll see you back here to look through the solution in a little bit. Okay, pause now if you want some more time to look at this one. But let's take that away so that we can look at this together. All right, so this time we just have a straight sum. There's no background context. This is not a real life situation. I just want to add these numbers or add all this list of numbers together. All right, now in doing that, there are formulas for doing this. There are some great big formulas for it. I try and stay away from those. Reason being, like, I always ask the question, what happens if it's question 19 on the second quant section in your GRE? You've got about a minute and a half to finish this question and the next one. You're under a real time pressure. Is your brain going to remember that very tricky, very intricate formula that well? I look at this in a slightly different way, and we can maybe give you a nicer way of thinking about this one that's going to stick in your memory a little more. So bear with me, I'll build up to this. Okay, so let's just ask, ignore the question for a second. If you were asked to find the mean of a list of numbers, find the average, find the mean of it. If you were asked to find the mean, well, then you would go and add up all the numbers, add up whatever list of numbers you've got, you'd find the sum, and we divide that by the number of numbers. Now, in this case, I'm turning this question around. I don't want the mean, I want the sum. So if I rearrange that formula, I could say that the sum is the mean times by the number of numbers. And all we need to do is go and find those two, and thankfully there's some nice ways of doing that. If I find the mean, I find the number of numbers, I multiply those two together. Thankfully on the GRE we've got a calculator to help us there. Find the number of numbers, that'll get us to the answer. Okay, so I'm going to deal with the number of numbers first because it links back to what we were doing in the last question, and I'm going to use that as a bit of a jumping off point. Then we'll go and find the mean. So in this question, if I draw another road, or like an analogy back to that last question, in this case, it's starting from 400, and I'm looking for all the multiples of 2. So 402, 404, 406, and so on, 596, 598, all the way up to 600. All right, so last question, we had that 330, we had that extra 10 meters at the end that wasn't a multiple of 16. In this case, we don't. The end point, all the way up at 600, that's a multiple of 2. The start point down here at 400, that's a multiple of 2. Now, in the last question, that first thing we did was 320 divided by 16, because 320 was the length of the road we could put speed bumps in according to that gap every 16 meters. In this case, the length of the road that we're dealing with here from 400 to 600, that's a 200 meter long road. And 200 meters, I can put in a speed bump every 2 meters, and so that would give us 100 numbers. But in the last question, I said, hold on a second, what about the start point? And in that road example, we could not put a speed bump at the 0 point, or we might have been able to, but I said, maybe. In this case, the question says 400 to 600 inclusive. The 600 is one of the numbers I need to include in my sum. So's the 400. So in the last case, when we had that road example, the 20 came from 16, 32, 48, all the way up to 320. It didn't include the 0 point. In the same way here, this 200 divided by 2, well, that's 402, 404, 406, all the way up to 600. It doesn't include this 400. So I need to add on 1 here to get 101. All right, so what the kind of the hand wavy way that we can do this is to say, well, look, there's a length of 200 here, and it's every even number. So 200 divided by 2, it feels like there should be 100 even numbers in this. But because the list starts and ends with an even number, in this case, the question is looking for even numbers, and this list starts and ends with an even number. So it starts and ends with the thing I'm looking for. Then I will have one more number than it feels like I should have. And so I've got 101 in this case. Now, if you're not comfortable with the kind of the hand wavy way of looking at it, we'll give you a slightly more formulaic way of doing this. What we can say to find the number of numbers in a list is we could say you take the big number, in this case 600, and we subtract the small number, in this case 400. We divide that by the gap between the numbers. In this question, we're looking for all the multiples of 2, so the gap would be 2. If I was looking for the multiples of 5, the gap would be 5. If I was looking for all the multiples of 10, the gap would be 10. So all 3 of these numbers change depending on the question. This is the big one, 600. The small one, 400. The gap, because I'm looking for multiples of 2, the gap will be 2 between the numbers. And then you add 1. So in this question, it would be 600 minus 400 divided by the gap, which was 2, plus 1. Which is 200 over 2 plus 1, which will equal 101. All right, so two ways of thinking about it. If you're comfortable with this sort of road analogy with the hand waviness and it's one more than it feels like it should be, fantastic, go for that. If not, when you're adding up a list of numbers, if they're inclusive, this will work each time. I take the big number, subtract the small number, divide by the gap, and then add 1 on the end. And as we say, in this case, the n that we're looking for is going to be 101. Okay, and that's one way of finding the number of numbers, and that's why we did the road question beforehand. All right, so that means that all we've got left to do now is to find the mean of this list. Okay, and what we can say about the lists of numbers the GRE are going to ask you to add up is that in those numbers, they are symmetrical, they're evenly spaced numbers, evenly spaced lists. And in an evenly spaced list, the mean is the same as the median. Now in this list, the numbers are nice, they're big, they're round, they're sort of whole numbers. If the mean is the same as the median, I'm looking for the median number that's right in the middle. So I'm looking 400 to 600, right in the middle is going to be 500. I could say that would be my mean. Okay, again, if that hand wavy way of doing things, if you're not quite too comfortable with that, another way of finding the mean in these questions is to say, well, I'll take the big number, I'll add the small number, and divide them by 2. So in this case, the big number is 600, the small number is 400, divide that by 2, so that's 1,000 divided by 2, which is going to give me 500. Right, so 500 times 101, the mean times the number of numbers, that's what we're looking for. Thankfully, on the GRE, we get given a calculator. I would dig that out at this stage. That means 500 times 101 would give me 50,500, which means the answer to this question is going to be C. So like I said at the start of this question, I try and stay away from those big formulas. If they work for you, fantastic, go with it. But what I find with lots of my students is when the time pressure's really on, their memory of that formula begins to fall apart. I find that this way of doing things is much more reliable for people, and hopefully those ways of figuring out the mean and the number of numbers make sense and you can work your way through these problems. All right, so what we'll do now is we'll take this process and sort of make it a little bit more complex. Like I said up at the start, if you're aiming for anything up to a 160, this is all you really need for the counting part of the video. If you want to skip the next couple of questions, go for it. If you want to stick around, no problem, but things are about to get a bit more complicated for the counting side of things. We'll bring the difficulty back down when we get to the sequences and then build it back up from there. So a little bit more complexity coming your way, same amount of time. See you back here in a little bit under 2 minutes. Okay, pause now if you want a bit more time for this one, but I'm going to take that question away. Very similar question to the last one. The extra difficulty comes in, we've made this a real life situation and we've tweaked the numbers around a little bit here and yeah, not giving you the explicit ask right there in the question. So let's take a look at the scenario and try and break down what this question's asking so that we can make it look like the last question and then you can see the similarities between the two. So in this question, Hemma's going to open an account and make the deposit each week. First deposit's going to be $5. She increases the amount of deposit by $5 each week. So $5, then 10, then 15. So our deposits are going to go 5, then 10, then 15, then 20, and so on and so on and so on. and we're asked how much has she got in the account at the end of the week in which she's deposited $200. So in that time, she's deposited 5. Next week, she deposits 10. Next week, 50. Next week, 20. Keep going, keep going. Next week, 190. Next week, 195. Next week, 200. Stop there. I want to know how much is in the account at that point. So we could rephrase this question to make it look like the last one. And it would say, what is the sum of all the multiples of 5 from 5 to 200 inclusive? Because here I've got multiples of 5, 5, 10, 15, 20. You've got the 5 times table there. I'm starting at 5. I'm going all the way up to 200. And then I want to add that list of numbers with the 5 and the 200 included. So in that sense, this is almost identical to the last question. I want to find the mean, I want to find the n, I want to multiply them together. Now that I've broken this question down, it's very similar to the last one. And so what we can do in a similar way to the last couple of questions is to think about, well, how many numbers do I have? I'm going back to that road analogy to begin with. Now, in this case, the length of the road, remember, this is not the 0 point that we've been starting with in the last couple of questions. It starts at 5. So the length of this road is actually 195. And I'm looking for 1 point every $5. And so we could do something like 195 divided by 5, and that would give me the 39. So I'm looking for the length of that road, divide it by the gap between the numbers, and that would give me 39. But as we've said, last couple of questions, whenever you think about things in that way, we're not including that first point. We're not including the start point of the road. So I've got to add one on, and that would give me the 40. All right, now, same way for those of you in the last question that didn't like that hand-wavy way of looking at things, we can still look at this more formulaic way of looking at things, the big minus the small divided by the gap plus 1. In this case, the big, that's 200. The smallest number is 5, divided by the gap, which was 5, and add 1, and we're going to end up in the same place. 195 divided by 5, and then I'm going to add the 1 on, and we're going to get 40 there too. So it doesn't matter which of those two methods you prefer, which of those methods works better in your head, you get to the same answer anyway. In this case, we have 40 numbers in our list, so I can fill in that part of the formula. So our number of numbers is going to be 40. We just need to find the mean here. Exactly the same way as the previous one, you can think about, well, 5 to 200, what is right in the middle of there? It's a bit more difficult to see in this case, so I'll go through that slightly more formulaic method. Because I've got an evenly spaced, it's a symmetrical list, the gap between each number is the same. In order to find the mean, I could just do the big number plus the small number and divide it by 2. In this case, that's 200 plus 5 over 2. 205 over 2 will give me 102.5. And that's going to be my mean, and I can fill that in that formula. And all I need to do now to find the answer is, again, get out the calculator, 102.5 times by 40. And if you do that, that would give you 4,100, which means the answer to this question is going to be D. So these sum questions, once you get into the swing of things, they can become quite formulaic. You can just like turn the handle and you do the same thing again and again and again. The way that the GRE will try and include some difficulty is to put it in context, real life situation, maybe disguise the list that you're trying to sum up a little bit. All right, one more question on the counting side of things. Now I'm going to get to a little bit of the problem solving side of things. So like I said, if you're aiming for anything up to a 160, you really don't need this, but feel free to stick around and stick with us as we go into some of the more complicated ways the GRE can talk about counting problems. So as ever, I'll get the question up on the screen, give you a chance to look at it, and I'll see you back here soon. All right, pause now if you want some more time with this one. All right, now this question on the face of it might not look like a counting question. I'm just looking for the value of a number. But if you think about that first sentence, the sum of 8 consecutive odd numbers is 32. We're using the same sort of principles, and I want to take a look at how we can manage this question without doing too much calculation. What a lot of people do, a lot of my students will do with a question like this is say, well, okay, I've got a list of numbers. I don't know anything about them, but let's just call the smallest one x. And then I'm going to add the next one, which would be, because they are consecutive odd numbers, the gap between them would be 2, so I'll add on x plus 2. And I'll add on x plus 4. And I'll add on x plus 6. And they'll keep going, and all those numbers will add up to 32. That's a perfectly valid method. It will get you there. What I'd say is it's going to get fiddly. Your chances of making an algebra error there are pretty high. And so let me maybe give you another way of looking at this. And like I say, we'll link back to those principles that we've been looking at so far. So I've got 8 consecutive odd numbers. 3, 4, 5, 6, 7, 8. We'll just get a list out there. All right. Now we know the sum of these numbers is 32. And I'm going to take you back to the last couple of questions when we've said, look, the mean of a symmetrical set, evenly spaced or symmetrical set, the mean is the same as the median. So in this case, the median is going to be halfway between the 4th and 5th number here. Now, if the median is the same as the mean, well, I can figure out what the median is. And so start the question, the sum of 8 consecutive odd numbers is 32. So if the sum is 32, then the mean of these numbers is going to be the sum divided by the number of numbers. It's going to be 4. The median here is going to be 4. And so because these are consecutive odd numbers, they're 2 apart, I know that number 4, I know that median is right in the middle of these two numbers. I can say that the 4th number is 3 and the 5th number is 5. And from there, I can find any number in the list because I just subtract 2 to go down the list, or I add 2 to go up the list. Now, the question's asking me, what is the third smallest number? So there's the smallest one, second smallest, third small. This is the number I'm looking for. So I just take 2 away from the 3, and I've got the 1. So you can make these questions significantly more simple by using this idea, the mean of a symmetrical, evenly spaced set. The mean of that set is the same as the median. And so we got the sum, we found the mean, it sits right in the middle. In this case, because there's an even number, then the median is going to fall right between 2 values. I can figure out what those 2 values are. And from there, I can figure out every number in the list very quickly. So it doesn't matter what the question asks. In this case, it was the third smallest. It wanted this one. Could have asked for any number in the list, and I can find it relatively quickly. So we can use that principle working backwards to simplify these questions and make them go from something which the GRE considers quite complex into something quite nice. All right, that's enough of the counting stuff for you today. Now we're going to move on to some of the sequences stuff. I'm going to dial the difficulty level back down. We're going to go back to first principles. What is a sequence? How is the GRE going to ask the question? So if you're one of those top end people aiming for something 165 plus, we probably don't have much for you in the next couple of questions, but come back to us. We're going to try and make these a bit more difficult towards the end of the video. For all of you people aiming up to a 160, hopefully we'll have something for you here. We'll get into what sequences are, how you should think about them, and we'll deal with the sort of the fundamentals of those in the next 2 questions. So I'll get this first one up on the screen, take a look at it, and I'll see you back here to take a look at the solution soon. All right, pause now if you're still working on this one. All right, so getting into sequences, the first thing you've probably noticed here is that we've removed a bunch of the words that you might have seen in the counting questions. Now we're going heavy on the algebra, and some people may not be familiar with what we mean by these subscripts. So that's where I'm going to start with this. All right, so this is just, it's a bit of algebra language to describe what's going on in the problem. So what the subscript's doing is it's telling us which term in the sequence we're looking at. It's an identifier. So the sequence is called A in this case, and that's just a letter. It just says this is the name of the sequence. I'm just giving it some kind of descriptor so I can talk about the sequence A. And each term in that sequence gets a number. So the first term would be A1, and the second term would be A2, third term would be A3. Now, each of those would have a value, but we use this subscript so that we've got a language and we can talk about the terms in the sequence. This is the first term, the second term, the third term. Now, when I get the n's in there, an just means I am talking about some general term in the sequence. I don't know which one, but this applies to any term in the sequence. And so this formula, an equals an minus 1 plus 7, what that tells us, now I've got a relationship between these two terms. This number, n minus 1, will be 1 lower than this one. Now, to get from this term, whatever it is, to the term 1 higher, I need to add 7. And what that tells me is as I move up the list, I go from one term to the next term. So from n minus 1 to n, I go from this term to the term 1 higher in the list, I add 7. So to go from A1 to A2, I add 7. From A2 to A3, I add 7, and so on. Okay. Now in the question, yes, we're given this formula as the setup. We're also told A6 equals 3. So I know what the sixth term is. So I could figure out the seventh term by adding 7. I could figure out the eighth term by adding 7 to that. If I wanted, I could work back down the sequence. I could figure out the fifth term by taking 7 away from A6. Then I could figure out the fourth term by taking 7 away from that. So these two pieces of information, this gives us a start point. We know what the sixth term is. And this top line tells us how to get from one term to the next, or if I reverse that, how to work my way down. So that's all the information I need. I can now figure out the value of any term in the sequence, which is great because that's what we need to do. All right, what we could do, okay, and we'll do this out in full so you can see the sequence working this time. I need to know the value of the 11th term. All right, I know what the sixth term is. So the sixth term, that's going to be 3. And as we said, to get from one term to the next, I just add 7. So A7 would be 3 plus 7, so it'd be 10. And we could keep this going. The 8th term would add another 7, it'd be 17. The 9th term, we keep going, 24. The 10th term would be 31, and the 11th term would be 38. Right now, but to shortcut that, watch what happens here. So we have made 1, 2, 3, 4, 5 moves. In total, I've made 5 moves. Each of those moves, I've added 7. All right, so what we could say is the overall move, rather than doing them one at a time, so I've moved once, I've added 7, I've added 7, I've added 7, I've added 7. I could do 5 moves. That means I'm going to add 5 times 7. Or in other words, I'm going to start with 3, add on 35, and I'm going to end up with 38. So for the sequences questions, if we can figure out the gap between the terms and know the number of moves we make, in this case 5, I can just do that number of moves we make, 5, multiplied by the 7, which is the gap, and that gives us the 35 here. Now, just to be careful so that we're not getting confused between what we've done in the counting, I don't add 1 to this, because this time I'm not talking about the number of terms, I'm talking about the number of moves we make. So in this case, I can just do 11, take away 6, and that tells me the number of moves I need to make. I don't need to add 1 on when I'm dealing with sequences, because it's not about the number of terms, it's about the number of moves I make. All right, so in this case, We found out that the 11th term was 38. Quantity A is 2 times that 11th term, and so that's going to give us 76. Now all that's left for us to do is to find out what the 16th term is. So I'm gonna go the shortcut way this time. To get from the 6th term to the 16th term, I need to make 10 moves. 16 take away 6 gives me 10. Each of those moves, I add 7, so the total jump is going to be 10 times 7. It's going to be 70. So I take my start point, which was 3, I add on the 70. Got those the wrong way around, sorry. 3 plus 70 will give me 73. So quantity B in this question is 73, quantity A is 76. So in this case, in this question, quantity A is going to be bigger, and the answer to your question is going to be A. Right, so in these sequences questions, you don't have to write everything out in this case. This is what I was doing to try and get that shortcut in there. What's happening each time is we're adding 7, and if you can figure out how many moves we need to make, in this case it was 5, in that case it was 10, if each move you add 7, you can just multiply the number of moves by how big each move is, and that gets you the gap between the terms. You can take your start point, add on the gap, and that'll give you the final value. All right, so I said that's hopefully the fundamentals of this. Hopefully you understand the notation, what we mean by these subscripts now. I'm going to begin turning the difficulty level up just a little bit, but hopefully you're going to be okay with this next problem. I'll get this one up on the screen, give you a couple of minutes, and we'll see you back here soon. All right, pause here if you want a bit more time on this question. Now, before we get into it, I probably need to give everyone a bit of an apology. I misread this question a little earlier, and it looked a little bit easier than it's appearing to me now. I'd say if you're struggling with this question, probably okay. If you're aiming for anything up to a 160, this is probably on the tough end of what you're looking for. You 160 plus people, hopefully you're getting this, but yeah, you up to 160 people, yeah, this is probably going to be challenging for you. See if you can follow the solution, and hopefully we can take something from this, but I wouldn't worry too much if this question was causing you some difficulty. Sorry for the mix-up there, but yeah, let's get into this now. All right, so word-based question here. Yes, there's a sequence here. We're told there's a certain sequence, and then this time we're given a description of the setup. So we can build up that formula using the subscripts this time, whereas last time we were just given it. So what we're told here is that each term after the first is found by multiplying the preceding term by 2 and subtracting 7 from the product. So I'm going to have some sort of relation between the nth term, this is the one I'm finding, and the preceding term, this is the term before it. Now the question tells me that I take that preceding term and I multiply that by 2. That's the multiply the preceding term by 2, and subtracting 7 from the product. So here's the product, preceding term multiplied by 2, subtract 7 from the product. So that gives me my formula from getting from one term to the next. That was the top line we had in the last question. Right, so I've got my formula. Now the rest of the question says if the sixth term is 39, what is the third term? So this time I'm going to put this up here because I'm going to use this a little later. But we get told the sixth term is 39, and I want to know the third term. So in the last question, we were going from A6 up to A11, or from A6 up to A16. We were always moving forward. This time, I'm moving backwards. I have the sixth term. I want to go down to the third term. This formula tells me how to go up. AN is bigger than AN minus 1, so I'm going up the sequence. I could very easily figure out how to find the seventh term. I just put 39 in here, multiply it by 2, take away 7, and that would give me the seventh term. But I want to go backwards. I want the third term. So what I'm going to do now is take this formula and rearrange it so that AN minus 1 is the subject, and that'll tell me how I can go down. So if I do that, first thing I would do is to add 7 to both sides. So AN plus 7 is equal to 2 AN minus 1. And then I divide. I'll just make that a bit more clear so that we don't get confused between the subscripts. And then I'm going to divide both sides by 2. So AN plus 7 divided by 2 is equal to AN minus 1. And now I've got AN and AN minus 1. I've got the lower term as the subject of this formula. This tells me how to go down a term. And so I can start putting the terms in. There's a bit more to it. I don't know the jump. Last time the jump was very easy. It was just add 7, add 7, add 7 as I was going up the sequence. This time, add 7 divided by 2. It's going to take a bit more work, and I'm only going from the sixth term to the third term. So I would do the algebra for each case in this one. So I can say the sixth term is 39. If I put that into this formula, I'm going to find out the fifth term. I'm going to find out one lower. So the sixth to the fifth term is going to be 39 plus 7 divided by 2, or 46 divided by 2, that's going to be 23. And now I just sort of repeat this process, kind of turn the handle, do it again and again. To go from the fifth to the fourth term, I put 23 into that formula. So 23 plus 7 divided by 2 is 30 divided by 2. That's going to give me 15. And to go from the fourth to the third term, I do this one more time, put 15 into the formula. 15 plus 7 divided by 2. So 22 over 2 will give me 11. So the third term in the sequence is going to be 11. So the answer to this question is going to be D. All right, so like I said up at the start of this question, sorry for mixing up the difficulty level. This is probably significantly more difficult than it might have first appeared. And yeah, like I say, if you're aiming for anything up to a 160 and you were able to follow along and get this question, wonderful. You probably don't need it, but great that you're there. What we're doing here is taking the text of the question and figuring out what the formula is to go from one term to the next. But this time I want to go down. So I rearrange the formula so that this time the lower term, the n minus 1, becomes the subject of the formula. And then it's just a case of repeating this process 3 times to get from the sixth to the fifth term, the fifth to the fourth to the third. That gets me the answer. And I can figure out which of the answer choices I'm going to go for there. All right, so yeah, as you can hopefully see, we're beginning to turn the difficulty level up on some of these sequences questions. The remainder of the video, we're just looking at how the GRE can take these questions and make them more complex. So this is where difficulty level is going to go up. If you're aiming for anything up to a 160, and hey, great job if you were doing this question, you don't need the stuff from now on. Stick with us if you'd like, but this is now for those people who are sort of 160 plus. We're aiming to get into those top levels on the quant section. So I'll get the next one up here, give you a bit of a challenge, and I'll see you back here in a couple of minutes' time. Okay, now's the chance to pause it if you want some more time with this one, but let me take that question away so that we can get to the solution here. All right, different way of defining the sequence this time. So that list at the top, the P1, P2, P3, PK, just tell we've got a sequence that's going to go on forever. We've got this general term PK, and we get told the first term here. So 3 cubed is the first one, and each term I find from taking the last one and multiplying it by a third. Now, I need to get up to P100 or P64 here, so I don't really want to be going and just doing, right, P1 is this, P2 is this, P3 is this, but I'm going to do that at the beginning to hopefully figure out a general term so that I can jump from P64. I want the 64th term. What is it? So if P1 is 3 cubed, then P2, I would put 3 cubed in here. 3 cubed times a third, well, P2 is going to be 3 squared. P1 is going to be 3. Sorry, P3 is going to be 3. P4, well, that would be 1. P5 would be 1 over 3. Or we could think about that as 3 to the negative 1, and that as 3 to the 0. All right, so what's going on here is I end up with, I can figure out a general formula for this, that P to the K is going to be P to the power of, sorry, it's going to be, not P, it's going to be 3 to the power of 4 minus K. Because when K is 1, 4 minus 1 up at the top here would give me 3 cubed. When P is 2, 4 minus 2 would give me squared. When K is 3, 4 minus 3 would get me the 1. That's what I'm looking for. I'm looking for a general setup here so that I can take them into quantity A and quantity B. So P100, if I put 100 in for K, that's going to give me 3 to the 4 minus 100. And P40 is going to be P to the 3, 4 minus 40. Or in other words, we've got 3 to the negative 96 divided by 3 to the negative 36. And now I'm getting my rules of exponents out and saying, well, I've got a division here, same base, so I subtract the powers. So we've got 3 to the negative 96 minus negative 36, which is going to give me 3 to the negative 60. All right, so I've got quantity A set up. Very similar thing with quantity B over here, P to the 64. Well, if K is 64, I'm going to have 3 to the 4 minus K, so 3 to the 4 minus 64 divided by P to the 4. Well, we've got that in the list. That's just 1. So we could have put that in there. If we get 3 to the 0, that's going to be just 1. Figure out the exponents at the top. That's going to be 3 to the negative 60 divided by 1, which is 3 to the negative 60. I've got the same thing for quantity A and for quantity B in this question. So the answer here is going to be C. Right, so I'm moving around the different ways the GRE could ask a sequences question here. In this case, what I wanted to get to was sometimes the best way to deal with a problem is to list out the first few terms in the sequence, see if you can figure out a general term, and then from there I can figure out what P100, P40 is and simplify the algebra down to an answer there. All right, we're going to look at different ways of doing it. I've got 2 more questions left for you. Different ways the GRE is going to turn the difficulty level up in these problems. I'll get the next one up on the screen, give you a chance to look at it. We'll see you back here soon. Okay, pause this one now if you want more time to look at this one, but let's take that away so that we can get to a solution here. All right, different way of defining a sequence here. Up till now, they've been what's called recursive sequences. And recursive means if I know the second term, I can find the third term. And then from the third term, I can find the fourth term. And from the fourth, I can find the fifth. You're moving up the ladder of the sequence term by term. Whereas this time, I've just been given a straight formula. That's what we were looking for in the last question. This time I've just been given it. If I want to know what the 30th term is, I can just put 30 in for n, and straight away there's my value. All right. So slightly different setup for the question, but I want the sum of the first 50 terms of this sequence. Now, I don't really know what's going on here as I first read this, so my first instinct is let's list out some terms of the sequence. Now, one of the not mistakes, but one of the things people might do is to jump a step or two. So that this formula works for all positive integers n. Now, the first positive integer is going to be 1. Now, you can hopefully see, well, 1 over 1 minus 1 over 2, 1 over 1 plus 1, that's 1, take away a half. The first term is going to be a half. Some cases that's right, but I'm not going to skip that step. I'm going to write this out in full, and you'll see why in a minute. So the first term would be 1 over 1, take away 1 over 2. The second term, and I'm looking for the sum, so I would add these. The second term, well, if I put 2 in for n, I'm going to have 1 over 2 minus 1 over 3. Keep going. The third term would be 1 over 3 minus 1 over 4. All the way up to the last term would be 1 over 50, take away 1 over 51. All right, so having written that out, what I hope you're seeing is that there's a bit of a pattern here. I've got negative a half, and then I've got plus a half, and I've got negative a third, or take away a third, and then I've got add a third. Now that pattern continues, and it would continue. We can write out as many of these terms as you like in order to see that. But what I can do here is, well, you take away the sets of parentheses because they're not doing anything. There's no multiplication there. And if I take those away, well, then I've just got subtract a half, add a half. Those two cancel each other out. Subtract a third, add a third. Subtract a fourth, there would be a fourth there all the way up to, and I can't do anything with the last term, subtract minus 1, so 1 over 51. There is no plus 1 over 51 to cancel that out. So what I'm left with are these two terms at the end. I've got 1 over 1, or in other words, I have 1. Take away 1 over 51. Okay, let's find common denominators there. I've got 51 over 51, take away 1 over 51, which gives me 50 over 51. There's my answer. Answer to this question is going to be D. So in these problems, when you get kind of this setup, they give you a formula straight out, and it's subtract two fractions, and it looks pretty nasty. Yeah, let's write the first few terms out. Maybe you need a few more to see the pattern here. I wrote the first 3. Maybe you need the first 4 or the first 5, and you're looking for do things cancel. Now, as I was saying at the start here, I don't want to skip the step. So this is the first step in the sequence. If I jump that first one, what I'd end up with writing is, well, the first term's going to be a half. And a half minus a third, that ends up being a sixth. And a third minus a quarter, that ends up being a 12th. And the next one, a fourth minus a fifth, that one ends up being a 20th. I can't see the pattern here because there isn't this way of cancelling things out there was in the line above. So just warning here, if you have the opportunity of writing the terms of a sequence out, please write them out just as they're written. You might need to go that extra step, but you might not. If you go that extra step without having that first one in here, you might not see the pattern. Adding up the first 50 terms of this sequence is going to be, it's impossible in the minute and 3/4 you have on the GRE. Whereas what I hope you see here is because we were able to cancel a load of terms out, and I ended up just doing 1 minus 1 over 51, this question goes from looking horrendous, it looks horrible, down to something that's actually very nice very quickly, and we got to the answer without too much problem. So like I say, if you get the opportunity, write that first term out. Don't do the clever thing of skipping a step, which means you might miss the pattern. All right. But in these questions, when you get something like the first 50 terms, add the first 50 terms, or find the product of the first 100 terms of a fairly horrible looking sequence, you're looking for a pattern. They do not expect you to add up all 100 terms, or 50 terms in this case, of this sequence. They expect you to see the pattern, cancel the problem down, and get to that answer, get to that more simple answer more quickly. All right, we've got one more question for you today. As we said, we're trying to turn the difficulty level up and show you the different ways the GRE can put difficulty into sequences questions. So hopefully you're finding these a little bit challenging. One more challenging question coming your way. As usual, a couple of minutes to take a look at this, and I'll see you back here to look at the solution in a minute. Okay, for the final time today, if you need a little more time to take a look at this question, now's your chance to pause the video. But let's take this one away so that we can look at the solution to this one. All right, so this question, the difficulty here, a lot of the difficulty is going to come from just the intimidation factor, the look of that algebra. So if you can see past that algebra, if you can get comfortable with it, maybe we'll figure out the first few terms. Hopefully this question will begin to look a bit nicer. So that's where I'm going to start. I'm going to break this formula down. Now, just like the last question, this is not a recursive formula. It doesn't tell us how to get from one term to the next. We can just throw the term number we want at it, and that'll tell us the value of that term. Now, what I'm looking for here is the sum of the first 10 terms of the sequence. So I want to know the first 10 terms of the sequence, or at least the pattern. So let's find the first few terms and see where we end up. So if I put j as 1 in to find the first term of this sequence, so c1, if j is 1, then I'm going to get -1 to the 1 plus 1 multiplied by a half to the power of 1. Or in other words, -1 squared times a half. Well, -1 squared is just 1 times a half. The first term is a half, right? Second term, and hopefully we'll begin to see the pattern in a second. Again, replacing j with 2, I'm now going to have -1 to the 2 plus 1, 1 half squared. So -1, 2 plus 1 is 3, -1 cubed, I'm back to -1. 1 half squared, there's a quarter, so the second term is going to be -1/4. Now, what I hope you're seeing as we do this is that the power of this -1 is going to bounce back and forth, odd, even, odd, even, odd, even. And so the terms are going to go positive, negative, positive, negative. They're just going to alternate back and forth. The power of the half is going up by 1 each time. So it's going to be a half for the first term, a quarter for the second term, an eighth for the third term, a 16th. And so we can begin to write out the terms of the sequence. First one's a half, second one's -1/4, third one is an eighth, fourth one is -1/16, and you can keep going as long as you want to see the pattern here. Now this time, sum of the first 10 terms. Last question was the sum of the first 50, and there was a nice cancellation. There was something in there that was great. Cancel everything down, the whole question shrinks, and all we had to do was 1 minus 1/51. That's not happening here. I'm not seeing a pattern that makes this into an easy sum straight away. And really, I want to find a way around. do not want to add up all 10 terms. I'm going to be here for some time. So I'm looking for, is there another way of thinking about this problem? Now, the benefit here, this is a quantitative comparison problem, so I don't need to know what quantity A is. I just need to know whether it's bigger or smaller than a quarter. So what I'm going to do is I'm actually going to draw a bit of a graph here and take a look at what the numbers do. And what I mean by that is, look, the first term is a half. So we'd have the terms down at the bottom, first term, second term, third term, and so on. First term here is up. There's a half. Okay, and the sum of our sequence is the x I'm putting on this graph. After two terms, so we've got a half plus negative a quarter, or a half minus a quarter, the second term, well, that's going to be here at a quarter. Okay, third term, I take the sum of the previous two, which was a quarter, I add on an eighth. So I'm going to be back to about halfway between the two. That's at an eighth. Then the fourth term, I'm going to take away a 16th. The next term, I'm going to be halfway between the quarter and the eighth. And this pattern of moving up, down, and going to being halfway between the previous two terms just keeps going. So the fifth term is going to be halfway between the previous two terms in terms of how high the x value is, but I'm going to put it in there. Sixth term, halfway between the previous two. And so, like we said, this question is not about what is the value, it's just, is it bigger than or less than a quarter? Well, because I know these terms are just bouncing back and forth and they're converging on something, that jump up and down is getting smaller and smaller and smaller, they're never going to get back down to this dotted line, which was a quarter again. They're always going to be a little bit higher. All right. I don't know what the number is going to be, but because I can see this pattern, because I can see what the sum is doing, I know it's always going to be bigger than a quarter. By the time I get to the 10th term, it's going to be bigger than a quarter. So quantity A, the sum of the first 10 terms, is going to be bigger than quantity B. So the answer to this question is going to be A. All right, so as I hope you've seen, the previous three questions, they're a little bit about pattern spotting. In this question, it was just, can I see that the sum converges and the gap between each term gets smaller and smaller and smaller? In the last question, it was about, what can I cancel? Hey, I can take out a lot of terms here and take this huge, great sum into something very small where I'm just summing two terms. And that's the key for these sequence questions. It'll probably take a bit of experience for you to get the feel for, when do I do what I do in this question and when do I do what I do in the previous question. It's a little bit of, well, let's just write out the first few terms and see what happens. Can I cancel things? Do things get simpler, or am I going to have to find a way around things? All right, so that's all I've got for you today. Hopefully that's given you an insight into how the GRE is going to ask you questions about counting, so summing up large lists of numbers, and about sequences, these ways of just dealing with lists of numbers and the sorts of questions they can ask you about them. We hope to see you back here at another one of our GRE Quant videos very soon. Thanks very much, everybody. Have a great day.